Hello everyone, in this video we're going to cover the basics of chemical equations. I apologize for my voice. I'm not sick. I've just been talking a lot the last couple days, so my voice is a little raspy, but I promise I'm not sick. Alright, let's get into chemical equations. There is already a Quizlet posted for the vocabulary that we're going to cover in this lesson, so make sure you check that out. So for chemical equations, chemical equations are what we use to represent, chemical reactions are represented with chemical equations. This is what we use to express what's happening chemically. Whenever there's a chemical change, we always represent it with a chemical equation. Here's an example of a chemical equation. We've seen a couple of these in class before. We haven't talked about them very much, but that's what we're going to do now, is we're going to talk about these things. Each equation, each reaction is unique, but they all have similarities. And it's the similarities that we're going to talk about, that we're going to focus on. Then we can get into the specifics and what makes each reaction and each equation unique. We're going to start with what are called reactants. So this is my chemical equation here. My reactants are what I start with. Typically, we find our reactions on the left, or our reactants on the left side of the equation. So in this case, it's going to be these two things right here, the CaCO2 and the Na2CO3. Those are going to be my reactants. Moving on to products. Again, using the same chemical equation, products, as the name implies, is what you end up with. It's the product. It's what is the production of. What are we making? Typically, it's on the right side of the equation. So that's going to be these over here, the CaCO3 and the NaCl. Those are going to be my products in this chemical reaction. We typically express states of matter with our reactants and with our products. And we use these symbols, G for gas, L for liquid, S for solid. Those are pretty self-explanatory. This AQ might be new for most of us. It's what we call aqueous. It's a water solution. We just talked about solutions. AQ is what we use to represent when something is a solution. So going back to our same chemical equation, solids can be crystals, they can be powders, they can be metals, etc. When they're reactants, you also have to remember that they can also be precipitates. Okay, whenever we have a precipitation reaction, that's what we're talking about, right? We're making a solid. In this case, our solid here and our products is going to be a precipitate. We're going to have some precipitation in our chemical equation, in our chemical reaction. Solutions, remember, solutions are clear, but they're not always colorless. Think about Gatorade, think about Kool-Aid, right? They're solutions, they're clear, but they're not colorless. And so our three solutions here, both of our reactants and one of our products, is going to be a solution. So we should see clear liquids. They're actually solutions, but we're going to see clear liquids. A little bit about equation notation. Using the same example. When we're using it in words and we're talking about things being mixed with, things being added to or combined with, reacts with, all of these, we're talking about these plus signs here. Okay, just like in math, in a math equation, in a chemical equation, every symbol means something. Okay, this plus sign isn't just plus. Okay, we're talking about where we could say mix with, we could say reacts with, we could say added to. All of these would indicate this plus sign here. Whenever we're talking about in a sentence, we're talking about it yields or it produces, it makes, it creates. That's going to be this arrow right here. Okay, when we start using sentences and converting them from sentences to equations and equations to sentences, it's very, very, very important that we know what all of these words mean, and we can convert them from words to symbols and from symbols to words. So that's a brief overview of chemical equations. If you check out the next video, we'll talk about how to interpret chemical equations.